Hello, Calculus 2. Um, so if I go to section 6.1 where this chapter starts, chapter 6, differential equations, number 6 is a good question. It says that verify that this function is the solution to this differential equation. So they give me a differential equation, they give me the answer, and they want me to verify it. So So it's not a debate whether it is a solution or not. It is, and I just have to verify it. Uh, and they haven't taught me how to solve a differential equation. So the way I'm going to do it is I'm going to plug it in and see if it works. And if I'm going to plug it in, I'm going to take this function y and plug it in for y. What do you think I'm going to plug in for y prime? The derivative. So I need the derivative. And I'm going to plug it in and see if it works, kind of like checking a solution. I'm going to verify that it's a solution. So they haven't taught me how to solve anything yet, so that's not what's happening in 6.1. And I taught you how to separate and integrate, or do a separation of variables. But the truth is, that won't even work for this differential equation. So until we learn some other stuff, and I don't even know if we can't solve this, and that's not the point. The point is not to solve it. They're giving me the answer. Please just check it and verify it. So if this is a question on a test or a quiz, you should do it. You should take the derivative. The derivative of an e function is very easy. The derivative is himself. The chain rule gives me multiplies by a -2. The chain rule is the derivative of that -2x, spits out a -2. So I did a derivative. It spits out this chain rule here, and I'm going to plug it in and see if this works. Here we go. 3 times y prime. Okay, there's my y prime. Plus 5 times the function y, which is this. Does that equal this? Negative e to the -2x. Well, that's a -6 e to the -2x plus 5 e to the -2x. When I add a -6 and a 5, I get -1 e to the -2x. Does that equal this other side? And indeed it does. So it works. It checks. So a little check mark, and we've done what we wanted. We verified the solution. I want to do another one. A little later here in the homework, I'm doing a little homework. There's this number 20. Number 20 gives me this function y equals 5 natural log of x. But then up above in the directions, they give me this differential equation. The differential equation they give me, and I call it a DE. The differential equation they give me is this. Y minus 16y equals 0. Anyway, I was about to say y to the 4th. Don't call that y to the 4th. When they put that's not an exponent. When they put that number in parentheses, that's another notation for derivative, and it's the 4th derivative. Another notation for the 4th derivative is y with, I guess, this Roman numeral notation. That's the 4th derivative. Or, y with 4 primes, but I don't know if you do 4 primes, maybe you do. Or d4y dx4. Anyway, notations for a 4th derivative. But here's one that you might not have seen. That's the 4th derivative. So anyway, and this problem says, is it a solution? Is it a solution? So, again, when they say verify, then it will be, just please go ahead and prove it. When they ask, is it a solution, I don't know if it'll work or not, but I kind of proceed the same way. I need to take 4 derivatives, plug it in there. I need to take the original function, plug it in there, and see if it works. I kind of doubt it does. I can already kind of see it doesn't on this one. But there's several problems around the 20s that ask you to check this. We'll do it for fun. What is y prime, the derivative? The derivative is a 5 over x, right, you guys? The derivative of log x is 1 over x times 5, okay? In order to do more derivatives, I kind of need to do power rules. I call this 5x to the -1. So here I go. Second derivative is -5x to the -2 when you subtract 1. I believe I did that right. Third derivative is 10 x to the negative 3. I think I did that right. And the fourth derivative is negative 30 x to the negative 4. So if I check all this, I plug this in, negative 30 over x to the fourth is another way to say that. I'm plug that in for that fourth derivative, minus 16 times the original function, 5 ln x. Does that equal 0? And the answer is no. So is it a solution? No. There's some others around there you could try, but that was kind of fun. Yeah, that's good. Let me show you, there's a few more. The beginning of the homework is about giving you the solution, checking it whether it really is, or verifying that it is a solution. Then they do get to some problems that they want you to solve. So I'm going to erase this. I'm sorry. I'm going to erase this. I should warn you, I'm erasing. You can hit pause if I start to erase, and you could, if you're interested in what's there. Here's one, number 50. I'm in 6-1, and they give me this differential equation, and they do say to solve it. So, find the general solution of this differential equation is what the directions are. Find the general solution of this differential equation. So, in my first video for this section, for this chapter, for this course, I taught you how to solve a differential equation. I said you separate and integrate. You do this method called separation of variables. Now, in 6-1, in a way, they haven't taught you that yet. But anyway, but that's what you do. Or what you might think is this. You might think, listen, they gave me the derivative. How do I get back to the function? I integrate. And you're right. And especially because these are all explicitly functions of x. So there is no y's over here where you have to separate the variables. In my previous example, in the previous video, I had to separate the variables. This is a little different. When it's just a function of x, you're right. All you got to do is integrate to get the function y. You integrate to get the function y. But technically, if you want to follow the method of separate and integrate, you could multiply the dx over there. So now you've got it separated. So the separate part is trivial or easy in these 6-1 problems in 6-1. They step it up in 6-2 and 6-3. But so it's very trivial. You multiply by dx and it's separated. So then you integrate. And of course you're going to integrate that to get the answer. But just watch this a second. If you integrate this, you are integrating a 1 with respect to y. Guess what you get? You get y. So the method works. Separate and integrate both sides. Separate and integrate both sides. This is a good integral. You should know how to do u substitution. That's a big part of this course. You let u equal what's under the radical. And then you find du, which is the derivative right here. So you do this derivative. We learned u substitution in chapter 5 leading up into this stuff. So u substitution is an important way to integrate. I like this. Here's what I like to do when I start to replace all this, because it's going to turn into an integral with u's in it. I see a square root of u. I see this 2, which I'm going to pull out front. The 2's out front. There's this x that's bothering me a little bit. But there's this dx. But an x times a dx, which is what that is. I could move this over. It's an x times a dx. That x times dx is right there. And that x times dx is a 1/8 du. If I move the 8 over, 1/8 du is x dx. So I replace this x dx. I replace that x dx with what it is. It's a 1/8 du. I put the 1/8 out front. So now I can integrate. That's u substitution on a fairly basic level. Some students struggle with that. And my advice is you should get good at it. You should understand the process and ask questions if you don't. That's a 1/4. This turns into a u to the 1/2. I've done all that work, but I have not integrated. Now I integrate. Add 1 to the power, u to the 3/2. Divide by 3/2, but instead of dividing by 3/2, I multiply by 2/3. There's a 1/4 out front. We put a plus c, and we're finished, except we're in u's, and we need to get back to x's. So the answer, y, is, by the way, I can clean that up just a little bit. What is that, 2/12 or 1/6? And that is my u to the 3/2. What is my u? Oh, there it is, 4x squared plus 1. So there you go. That's called a general solution to the differential equation. The challenge in this one was not to separate. That was very easy. The challenge on this one was to integrate this little u substitution work. So there's a little batch of problems in 6-1. There's a nice little batch of problems where basically they're easy to separate, but then you integrate. So that's good. You know, this chapter 6 is a good place to start. We're in this new world of differential equations, but we're doing a lot of, I did some derivatives to verify, and now I'm doing some integrals to solve. So I'm reviewing Cal 1 in a way a little bit here. It's a good way to start Cal 2. A little review of Cal 1 in the context of chapter 6. All right, good luck.